Today, we're here in beautiful Haw River, North Carolina, visiting Andersen Products, an American-based manufacturer of surgical and infection control equipment. My name is Justin Poulin, and I want to welcome you to the premiere episode of Beyond the Tour. This series represents our latest effort to introduce you to the leaders in our industry and increase public awareness of the challenges facing sterile processing professionals every day around the world. Our tour begins at the Eddy Pub, located along the Haw River at the site of a former textile mill. We're meeting with Andersen CEO Ted May and the chairman and founder, Dr. Harold Andersen, to learn more about this family-owned business and how it all began.
When I was a resident, probably a first-year resident at Bellevue Hospital in New York, I had two patients within a relatively short time who had complications because the nasogastric tube was not working and we didn't know it. It's passed down and it drains the contents of the stomach, and when it stops, you assume that the stomach is empty. But it could be, of course, that the tube is kinked. So you don't really know whether you've actually done what you think you've done. It stimulated me to think of, is there a way around this?
Dr. Andersen's professional experience as a surgeon complemented his innovative spirit. It allowed him to create a solution by inventing the biluminal tube, in which air is drawn down the small tube and back up the large tube to ensure a patient's stomach is emptying properly. Colleagues of his began asking about his new device.
I got a call from Minnie Biffer, who was in charge of central supply for Bellevue. Now, Bellevue was a very big hospital, and she had a very big job. And I thought she was going to admonish me for using too many elasticized bandages or something like that. But actually, she said she had heard of this tube, and one of the senior surgeons had asked her to get some. Where could she get them? I said, I'm making them in my room. But my father was interested, and he was in the business of managing an automobile spark plug company. And he had made some changes and some dyes that made it easier to make the tube. And I said, well, we could ask him if he'd be willing to make it for the hospital. You know, how many tubes are we talking about? She said, well, we'll start with 1,000. I said, 1,000 tubes? Couldn't imagine it. But at any rate, we called my father and told him the story. And he said, sure, we'll make them. And that's how we got into the medical products business.
So Dr. Andersen is like the surgeon innovator. He comes up with nasogastric tubes, which solves one problem, but creates another one. He has to figure out a way to sterilize them, and he comes up with this disruptive technology with the glass-sealed ampule.
Right, so they're taking ethylene oxide, a flammable chemical, putting it inside of a glass ampule to deliver that to medical devices to sterilize them. That's the real innovation here.
Back when I was working with this chemical, we had these giant tanks that were behind the autoclave that were combustible. Everybody was worried about an exposure or an explosion. And he has taken this technology and made it so safe with such a small amount of ethylene oxide. It's almost mind-boggling. And the impact that he's having worldwide with it now, touching patients' lives literally around the globe, is really amazing.
I think it's important for everybody to understand the scale here, because you're talking about this gigantic room and these big tanks, and now they've taken that and put it in a small glass-sealed ampule, so the amount of ethylene oxide is so much less.
Yeah.
Good morning, everyone, and welcome to Health Science Park, the home of Andersen Products. We are so pleased today to have the hosts of the Beyond Clean podcast and media empire here. We're especially pleased to have a number of guests here, and Our guests this morning are longtime Andersen customers. We have Dr. Joseph Hunstead, who is a nationally renowned aesthetic plastic surgeon. Dr. Hunstead has been in practice for 32 years. He's been using our system for well over 20. And we're so pleased to finally have you up here. With him is his registered nurse, Kristen Morrison. And we're really glad that you're here to learn a little bit more about what we're doing. And I'm particularly pleased to have Suzanne Babcock here, who is the chairman and CEO of Sivatech, which is an innovative medical device startup here in North Carolina. And we've been working with Sivatech literally ever since it was a concept. Today we're going to be taking a tour of the Andersen manufacturing facilities. This is a very special opportunity for you to learn a little bit more about the equipment that you've been using, but it's also a very special opportunity for our employees to really understand how the equipment's used. These sterilizers have hundreds of parts. The employees that you're going to see are all playing a piece in the manufacture of this equipment. A lot of them have been with us for 20, 25 years. They've never had a chance to talk to a customer before, so welcome. You talk about bacteria evolving, and people talk about superbugs, and that sounds kind of cute. It's a bug, it's super. The proper term is multi-drug resistant organism, and this means an organism, a pathogenic disease-causing organism that cannot be killed with antibiotics. And this is really scary stuff. I mean, you catch one of these bugs, it's transferred to you, and the surgeons involved have very little recourse. And there is a growing number of these organisms that are resistant to the antibiotics of last resort, meaning that there are no drugs left. Ethylene oxide, again, is the one chemical that FDA has recommended to really address this problem.
Surgical site infections remain problematic. They say that anywhere from 2 to 5% of your surgical patients may get a surgical site infection. So I've always asked the question, why are we not doing everything we can, and why is that not the top story on the news until that gets fixed? And ethylene oxide, in my mind, sounds like it could be a fix if we've got something that we know CRE cannot defeat. Why is it not already implemented on a grand scale to try to prevent these deaths and these infections?
I've heard it said that it's only 1% of the uses of a duodenoscope, but in as much as 600,000 duodenoscopies are done annually, that's still a pretty high number.
Mm-hmm. It's 100% if it's your wife or your child that gets that infection.
True.
A lot of American companies these days talk about their stuff being designed in the United States, and we actually make our products here. And being an American manufacturer means that we're using a lot of other companies in the community. So this metal, for instance, is laser cut at a local facility. It comes here, and Wayne at that point takes it on and starts the bending process and taking raw metal and turning it into the cabinets that we use for our sterilizers.
Andersen designs and manufactures products in the U.S. using raw material, like this metal used to make sterilizer cabinets, sourced from local North Carolina manufacturers. Once the manufacturing process is complete, Andersen sends these sterilizer cabinets to 52 countries around the world.
Wayne, thank you very much.
Yes, sir. Thank you very much.
Appreciate it, and hope we haven't disrupted things too much here.
No, you haven't. Not at all.
Very good. Okay, so this is a really fun department. And I say fun because I think there's an element of magic in this place. We sell about 1 million of our ethylene oxide cartridges every year. And this is Nick, he's the head of this department.
Nick walked us through how plastic pellets are melted and injected into molds for Andersen sterilizer parts, including the ethylene oxide, or EO, cartridges. EO can kill all known viruses, bacteria, and fungi, annihilating even the most sterilization-resistant types of microorganisms called bacterial spores. Nick also explained to us what happens when the manufacturing process doesn't go according to plan.
If it's not running right and parts come out not usable, we take and grind the parts up into little pellets, about that size, one of those. Then we mix it with our virgin material, 25%, and we remake the parts.
You don't want to drop that because it's really slippery.
Yes, it is.
He's using both hands.
Yeah. That was on purpose.
Fantastic. Nick, thank you very much. Appreciate it.
Thank you.
I certainly wouldn't have gotten into that business without my father. My wife, who is an internist, also helped a great deal in the early part of putting the company together. She did examination of our employees to be certain that we weren't poisoning anybody. My son, who's an orthopedic surgeon, is actually the president of Andersen Sterilizers, which is the manufacturing arm, and he'll tell you that he was raised on the factory floor.
It sounds to me like we're talking about a family. We're not talking about a company.
There's a lot of truth in that.
I am particularly pleased to have all of you in this part of the company. One of the big reasons is the person you're about to meet. Leonidas Newland is literally one of the people that built Health Science Park. Leonidas has done pretty much everything around here. Is that fair?
Yeah, that's fair to say. I've been a lot of places.
Previously, we had seen the parts that Wayne bent up, and this is where the individual parts are put together. And this is one of our sterilizer cabinets. I will mention that this is all stainless steel, and working with stainless steel, as Leonidas does, is a little bit like tightrope walking. With other metals, you paint them, you can hide your mistakes. With stainless, you make a mistake, there's a bad scratch, and you can buff some of them out, but you got to be really good, and that's why we have really our senior craftsmen here.
Leonidas helped construct the buildings of Health Science Park 60 years ago and has since worked in many departments from maintenance to manufacturing, a loyalty that has helped make Andersen what it is today.
How important is that to the culture, that the employees feel like they can grow within the organization?
Our success has really been built upon the people like Leonidas who've made a career here, and a lot of whom now have sons and daughters and other relatives working here. A major benefit for us is being able to retain people for a long time and have them participate in our growth.
What do you like best about your job?
I just like to do it. Yeah. I like what I do.
Leonidas, thank you very much. Really appreciate the chance to bring everyone by, and I really wanted them to see your department.
Thank you very much.
We talk all the time about career ladder in sterile processing. All anybody wants to do is grow within the organization. And one of the things that's really neat about Leonidas' story is he started kind of at the ground up, and he's worked in almost every department within Andersen.
He literally helped build the buildings that he's working in now.
I love the pride that you could see in his eyes. I'm only talking about his history, but that same pride you can see in the eyes of sterile processing technicians when they finish a tray, when they finish a wrap.
This equipment is used, as all of you know, literally to save lives. And one of the company's mission statements is helping our customers to create miracles. And everybody on our staff is pulled in quite regularly to get a sense of that. We tell them stories of the doctors who are coming up with cutting-edge techniques using our equipment, the medical device engineers who are coming up with their own next-generation disruptive technologies. And we're not making those new devices, but our sterilization process is critical to it. And everybody on campus is playing a part in that. And I think that this has really helped to give them a broader sense of, what they're doing is making a difference in the greater world.
The fact that this is a North Carolina company and they source a lot of the materials in terms of manufacturing from local companies, that is a testament to a commitment that they made on their part to keep this central to the U.S. and even more so to the community around them.
This is another very exciting department in the sense that this is where our most complex and really state-of-the-art equipment is manufactured. Ethan Marshall is the head of the department. One of the things I'd like to stress, you've seen our little tabletop sterilizers, and Dr. Hunt said you've been using those for years. We make larger models. This is one, and you can see the one that's the size of a refrigerator freezer in the back. We try and produce a range of models that will provide sterilization resources for small facilities all the way up to hospitals and major device manufacturers.
The EO gas machines operate on a heated cycle, which means that not only is sterilization time reduced, but the time between surgeries is also reduced, leading to a healthcare facility's ability to operate on patients safely and efficiently.
This can also run down as low as 35 degrees, and we have a lot of manufacturers of drug-coated devices that are using that very low temperature cycle to protect the efficacy of the drugs they're sterilizing.
Yeah, that's interesting. Might need another one.
We can help you with that. Justin, we were talking previously about the environment and growing concerns about the release of chemicals into the environment. And Dr. Hunstead, behind you, we've got the shell and the heart of one of our scrubbers, which we refer to as an emissions abater. This runs on a very simple cartridge that chemically captures the ethylene oxide that's released from our systems. And we are calling this a zero emission process when you use one of our abaters. In truth, you're releasing about 0.17 grams of gas per cycle. So it's not zero, but it's pretty darn close. And that teeny amount of gas that is released disperses almost immediately. And so we're very proud of the fact that we are providing scrubbers to all of our customers in California, the other particularly strict air quality districts around the country. And as environmental concerns become a bigger deal, I expect more and more of our customers are going to be using this type of emissions control equipment. And we are unique in the sense that we have a dry chemical bed that captures the ethylene oxide. Most emissions control equipment burns the ethylene oxide. And ethylene oxide is potentially explosive, so burning it can be problematic. Ours is a much simpler system.
If you go into an acute care facility, a big hospital, the abater is 5 times this size. So the footprint that you're using to save space for everything is...
The abater is 5 times the size and it's 10 times the cost.
Yes.
So let me show you the biggest of our sterilizers. And Ethan, do you mind being the demonstrator for this? Come on back, guys.
Andersen manufactures ethylene oxide sterilizers in multiple sizes to accommodate different size facilities. EO sterilizers are being recognized in hospital settings as one of the most reliable ways to stop hospital-associated infection outbreaks.
Okay, well, thank you, everybody. We are here in our accessories department. This is Laurie, the manager of the department. She's been in charge for 10 years now. And I like to bring people up here because we manufacture all of the accessories that are used with our sterilization process. And we're one of the few companies that do that. We do it really out of necessity. And by that I mean, we have gotten samples of other people's sterility indicators and accessories, and frankly, they haven't met our standards. And so Laurie and her crew have been making the essential accessories for our process for really ever since Dr. Andersen started, and Laurie, you've been doing it for 10 years.
Here in this department, a complex manual process takes place. It is labor-intensive, and the level of art and skill required can only come from human hands.
This is the second place we've been where we've really seen, I almost want to say it's a form of art. The work that's being done can't be replaced by machines. Must be hard to find right people. Like, you have quality people, and once you find them, you keep them.
Yeah, it's hard to find people that can stand the heat back there to manufacture the dosimeters and being able to maintain it and be able to get the gaps out, because it is glass and it breaks easy. It is a struggle.
Well, Laurie, thank you very much. We appreciate the chance to come by and show some of our customers what you do.
Hank had a really interesting conversation here last night with just some people asking what we were doing here. And what kind of spun out of that conversation was Hank's concept around what true informed consent should look like.
Yeah, if patients really knew the challenges that they were walking into, would they still do this procedure? And if we know that our scopes are not getting fully sterilized, and if the patient understood the risk associated with that, would they still sign up? Because oftentimes, as I'm talking to folks outside of our industry and they find out what we do with sterile processing and what that is, and even that they reuse the surgical instruments, a light bulb goes off. It's like, oh my gosh, what you do is hugely important, and oh my gosh, what I'm about to do in my surgery is risky. And the answer to some of this, like we've talked about multiple times through Beyond Clean, is not only engaging and equipping our industry to do the right thing with the right products, the right procedures, also though to inform the public so that they know and can be asking their providers, are you doing everything that you can be doing to protect me? And if not, why not? Is it just good enough, or is it really best practice?
Hank, this is where I think you and the rest of the team deserve major credit. You've been shining a light, trying to bring some understanding to a part of the healthcare industry that has gotten very, very little attention, certainly in my lifetime. You're absolutely right. Most patients are completely unaware of not just potential risk, but how instruments are disinfected or sterilized, and what that difference means. I think it's great that you guys are helping to bring this knowledge and this awareness to the general public, because nobody else is doing it.
Dr. Andersen, you talked about how when you created the nasogastric tubes, the manager of sterile processing called you and you thought you were in trouble. And I think honestly, the effective partnership of all the different teams that are involved in surgical services is really critical, because again, to the general public's concern, they're coming in expecting a standard of care where it doesn't matter if they're the first scope of the day or if they're the last scope of the day, that they're getting the same quality as whoever came before them and whoever comes after them. And I honestly feel that how well these teams work together is critically important to achieving at least 99.9% of that standard of care expectation.
Our company is trying to make it clear that you could be certain that you have a sterile instrument to use every time. Not 99% of the time, but every time.
Well, this is where the tour ends. This is our warehouse, and it's from this point that we're shipping product, not just around the United States, but again, all over the world. You can see behind me, we've got about 600 gas kits that are palletized and ready to be shipped off to Latin America in this case, but it could be anywhere.
Ted, thank you very much for having us here at Andersen Products. You're an American-based business giving life to the community. Your culture really stood out throughout this tour. I just want to commend you for what's happening here. It was a really special opportunity for us to be able to speak with Dr. Andersen and talk about how he started as a surgeon, then an inventor, and now is making products that are changing the industry. So thank you very much. And I do want to thank Kristen and Suzanne and Dr. Hunstead for coming along. And thank you for joining us on this premiere episode of Beyond the Tour.
We're putting a flammable, toxic volatile in a flame-sealed glass ampule. And that clearly is impossible. But we've been doing it for 60-some years.